Hi guys! Welcome sa ASIC9. In this video ay tutuloy natin yung series natin on calculus. So sa previous video, napag-usapan natin yung dalawang problems where calculus originated. Yung una, yung tangent problem, kung saan ang problema ng mga mathematicians was to find the slope of a line tangent to a function. No? So again, uulitin ko, madali lang yung slope. No? Pag meron kang dalawang points na x sub 1, y sub 1, tsaka x sub 2, y sub 2. You can use the formula of the slope m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, yung problema ng mga mathematicians dito ay isa lang yung point na given. Yan yung point P, no? Which means na hindi natin pwede gamitin tong formula na to. So, ano yung ginawa nilang paraan? Ang ginawa ng mga mathematicians dahil hindi nila makompute yung slope ay gumawa sila ng another point dun sa function and then for example, we name that point Q at pagkatapos ay line through point P and point Q. Yung line na yon ay red line dito sa diagram natin at yan yung secant line. Now notice that as Q approaches P from the right, palapit ng palapit yung red line dun sa green line and halos magiging pareho lang yung slope nila, di ba? Pag ang dalawang lines ay magkapatong or coincident, magiging equal yung slope nila. So as Q approaches P from the right, the slope of the secant line gets closer and closer to the slope of tangent line. Pagaling naman dito, ganun din. Palapit din ng palapit yung red line dun sa green line, which means na malapit yung kanilang slope. And we want to make Q very, very close to P, pero ayaw nating pumatong din siya kasi pag pumatong siya, magiging isang point lang din. No? So this method is summarized here. Una, as Q approaches P from the right, the slope of the secant line approaches the slope of the tangent line. No? Tapos as Q approaches point P from the left, the slope of the secant line also approaches the slope of the tangent line. We want to make point Q as close to point P as possible, but not coincide with point P. No? Kasi pag nagpatong sila, again, magiging isang point lang siya. At balik tayo dun sa unang problem na hindi natin makukuha yung slope kasi isang point lang. Now, itong konsepto na ito kung saan nag-a-approach pero hindi magiging equal or hindi siya lang magpapatong, ang tawag natin sa konsepto na yan ay limit. The limit of the slope of the secant line as Q approaches P from the left and from the right is equal to the slope of the tangent line. Now, inaral din natin sa previous video itong area problem, no? Ang area problem ay pag-approximate ng area and we have done this using rectangles. There are other ways, no? Pero I think ito yung pinaka-intuitive. Now, sa previous slide, pinag-usapan natin yung approach from the left and from the right. Pero ito parang hindi natin na-discuss dito sa area problem. Well, meron din yan, no? So, here's an example. So, meron tayong area dito na kulay blue na gusto nating kunin, no? Pero nilagay ko na lang yung numerical value. And notice na meron tayong divider dito. This is a Cartesian plane and ito ay number line. So magkahiwalay ito, no? Magkaibang window yan. And yung 2.33333 and so on na yan, ito yan pag pinlat natin sa number line. Pwede rin natin i-approximate yung area na yan, no? And ito yung isang approximation. Maglalagay tayo ng isang rectangle. And in fact, yung rectangle na to ay square. Ito ang kanyang length. Ito ang kanyang width. So 1 by 1 siya. Kaya square siya. And yung area ng square na yan ay 1. So ito yan, no? And ang numerical value niyan ay ito. Yung 1 dito. Pag dinamihan ko yung rectangle, sana napapansin nyo doon sa area. Lumiliit yung bakante, di ba? So ibig sabihin, ina-approach niya yung actual area under the curve, no? And kung mapapansin nyo, that is consistent with the value here, with the sum of the areas of the rectangle. And also, yung L dito approaches A from the left, no? So, palapit na palapit siya dun sa A. Okay, and we can make as many rectangles as we can, no? Theoretically. Now, balik tayo dun sa nag-iisang rectangle, no? Hindi lang ito yung way ng pag-approximate. Dito, ang vertex ng rectangle na nag-i-intersect doon sa graph ay yung upper left. Paano kaya kung upper right? So, ito naman yung approximation niya. So, sobra ito kulang, no? And yung area niyan ay ito. Halos 4 na, no? And as we increase the number of rectangles, ano napapansin nyo dun sa area na mas lagpas? Lumiliit din siya, no? So, pareho sila lumalapit doon sa actual area, no? And kung makikita nyo, yung upper sum niya o yung overestimate ng area, and kung titignan nyo yung view dito, it also approaches the actual area from the right. So yung lower sum approaches the actual area from the left, and yung upper sum approaches the actual area from the right. And pag dinamihan ko yung rectangles, both the red and the green points approach the blue point, which represents the actual area. So let's summarize the ideas. First, alam natin that the sum of the areas of the rectangles approximates the area of the graph. Alam natin yan, and pag-aralan natin sa previous video. Pangalawa, as the number of green rectangles increases, the approximate area approaches the actual area from the left. So yung green na rectangles, yun yung underestimate ng area, no? Yun yung kulang. As the number of red rectangles increases, the approximate area approaches the actual area from the right. So yung from the left and from the right, kita siya dito sa mga points na to. Habang dinadamihan natin yung rectangles, palapit sila ng palapit pareho sa actual area. The lower sum approaches the actual area from the left, and the upper sum approaches the actual area from the right. Now, the limit of the approximate areas as n increases is equal to the actual area. Now, the phrases approaches from the left and approaches from the right are informal ideas of left hand and right hand limits. Pag-aaralan natin yan later, no? And yung left hand and right hand limits are very important ideas in understanding limits and continuity. Now, the idea of left hand and right hand limits goes back as early as Euclid, no? And kung makikita nyo dito, to approximate the area of a circle, we can inscribe polygons, no? Inscribe nasa loob ng circle at circumscribe nasa labas ng circle. Yung left hand limit ng area ng circle ay yung nasa loob, no? Palapit siya ng palapit sa area ng circle, pero from the left siya kasi mas maliit siya dun sa area ng circle. Yung mga circumscribed polygons naman, yung nasa labas, from the right naman siya kasi mas malaki siya dun sa area ng circle. So dito sa video na to, ang napag-aralan natin ay the intuitive idea of left hand and right hand limits. And sa mga susunod na videos, pag-aralan natin yan formally, and at the same time, paano na pag nilagyan na natin ng numbers, no? Paano pag nilagay na natin sa function. Okay, so abangan niyo yung susunod na video. Huwag niyo kalimutan mag-subscribe and invite your friends para may makasama kayong mag-aaral ng calculus. See you!